Good evening, all. Welcome. This is an Energy Committee sponsored SAFE program. Quite a number of our residents have joined senior stewards acting for the environment. They are not part of the CRA committee group, so the Energy Committee is the sponsoring organization tonight. I'd like a show of hands of SAFE members and a show of hands of those who have been involved with an energy program on thermostat setbacks peak. That gives you some idea of our involvement. We are an enthusiastic, hungry for information group. I'm going to turn this over to Sue to do the introductions. Glad you're here. Thanks.
Thank you, Ben. Hi, everybody. Good evening. I have a few notes here. I have such a special, unique...
Can you use the mic?
Is it on now?
Yes.
Okay, now it's on. Thank you. I'll start over again. Thank you, Ben, and good evening, everyone. I have a few notes here because our very special and unique speaker has such an extraordinary background that I want to get everything right. As you understand, I am also a member of Senior Stewards Acting for the Environment. And because of that, when I heard John Conrad speak at my church, a light went off. And I thought, I have to make a phone call. After calling the chair of that particular church committee, I then became connected with John Conrad. And he's easier to find than you might think. Look, Google. So let me just give you a very brief biography of John. And mostly everything is in plural, all right? Astronomical engineering degrees, U.S. Air Force Academy, Purdue University, leadership in space programs for the Air Force, NASA, Department of Energy, and Industry, managing satellite rocket launches, designing and operating military and civil aircraft, data application in areas of as earth science, intelligence, astrodynamics, and astronomy. So now, retired and as a NASA ambassador, he's here to speak with us. And just know that he also gives many lectures to a wide range of audiences. And they would include schools, astronomy clubs, museums, libraries, and other venues. For us, even as we live in this very rough reality of climate change, I think we can really celebrate that we do have NASA and the decades of past data and amazing exploration that they have done for the benefit of us. So I must say that there is one way of describing what NASA does, and we all have our very special understanding of what NASA has meant to us in our lives and through the decades, and what it has meant to us for our country. But one way to describe NASA is NASA explores the unknown in air and space, innovates for the benefit of humanity, and inspires the world through discovery. So some of our information tonight will be a bit rough, just as our new climate is, but I believe we will be inspired, and keeping in mind that we have many working for decades at NASA and elsewhere whose goal is to benefit humanity. And with that, I would like you to welcome our guest, John Conrad.
Something always goes wrong at first. Breaks the ice a little. if it'll stay put now. Thank you all for coming. And thank you, not just personally, but on behalf of NASA. And she said some wonderful things about NASA. And I want to point out that we all share something with regard to NASA, and that's that their programs are quite expensive and we're all taxpayers. So almost first and foremost, the reason I took on this role of being a NASA ambassador, which incidentally is a role that's played by about 1,000 people across the country in different states, all of whom are space enthusiasts and many of whom are educators of some sort or another, and some of us are engineers. But the fact is that I believe my mission very often with the audiences that I prefer, folks like you, astronomy clubs, adults in general, is to make sure that you understand what your tax dollars are going for. And I hope you will be impressed because whether you find it to be sufficient or not, it's completely necessary that we have NASA right now in order to understand this challenge that the world faces. Climate change isn't an American problem. The weather, climate, have nothing to do with national boundaries. They don't have anything to do with Republicans and Democrats. It's a real problem that everybody else in the world, in addition, hopefully, to all of you, but certainly most Americans, understands is one of the crises of our time. And even though probably we aren't going to be directly impacted, and by that I mean you, my contemporaries, us in this room, our kids will be, and certainly our grandkids will be pretty significantly, and their kids will really be impacted by it. And unfortunately, we've lost a march of not just a few years, but of decades now in not getting started. And I wish I had the answer, and you're not going to hear it from me tonight, unfortunately, of a large-scale answer for how we finally address this very, very big problem. But I've been encouraged, as I'll mention toward the end, by what I'm finding at places like Crosslands. So let me get on with it here. And the beautiful Earth that we live on, at this view from outer space, looks so clean and nice. We know what it's really like down on the surface. You folks have an extraordinarily nice environment here at Crosslands, but a lot of the world doesn't. And so a lot of you are sensitive to the environmental problems. But tonight, we're going to talk about the fact that we wouldn't know all that we do about climate change by far if it weren't for the view from space. So that's really the reason that I'm here from NASA talking about it. So I never like to bury the headlines, as the saying goes these days. I'm not going to lead up to something and then spring it on you later. Right now, just because already you folks are seeing it, we're seeing headlines this summer in particular, in my experience, probably more than we've seen in the last generation. You just can't avoid it at this point, and it's hard to understand how anybody can deny that there's global warming. Here we had July, which turned out to be the first time that a summer month was more than a degree Celsius, which is about 2 degrees Fahrenheit, above any previous June. That was June. Then came July. We forgot about June and July because July was really hot. And July didn't just become the hottest July ever, it became the hottest month, not just in the history of what we point out all the time as the precise temperature understanding we have in modern times, which goes back about 150 years, but going back well over 1,000 years. We are able with paleoscience now to look at ice cores, not just tree rings, but the geology in many ways, and look at the chemistry and the makeup and the temperatures of our Earth going back for thousands of years. And July was the warmest month ever. In addition to what you've been hearing in the way of carbon dioxide, which has gotten most of the press for a few decades, methane increasingly is becoming understood to be a big problem. We're going to talk about that too. These are all headlines from the local papers since June. We've heard a lot about Greenland and the ice sheet. It turns out now we're hearing more and more about Antarctica, which is much bigger than Greenland in terms of ice that could go into the oceans and raise the ocean levels. And we're starting to see some pretty big declines there, which we'll talk about. And finally, I wanted to mention a name that hopefully some of you recognize. There's an organization that NASA has in New York called the Goddard Institute of Space Studies, GISS. And Robert Jastrow, who was a famous astronomer, was the first leader of that for a couple decades in the 20th century. And when he finished, James Hansen took over. And I'm going to tell you what happened with James, as it says 35 years later. That's as of today, so in 1988. And it'll probably surprise some of you. But a very, very important NASA scientist. And then finally, I try to keep up to date with the news. So this just actually came out. Well, this one is from a couple months ago yet. And it allows me to make a point about a science that nobody's probably heard of as being a technology, and that's attribution. And so if you picture sitting around the table at dinner or lunch or something when there's been a bad weather storm or snowstorm, and somebody gives their opinion that this is due to climate change, and somebody else says you're crazy, that it isn't. And so they go back and forth. I mean, it happened in my house. It's probably happened in most families, and certainly in schools and companies. But the fact is that because we understand the statistics now of weather events, and we understand what the climate changes are doing, they've actually come up with a technology to make the judgment as to whether any particular set of wildfires or drought or heat wave is actually attributable to climate change as opposed to just being another excursion of the weather, which of course we all have to live with because nature changes all the time. So attributions become a centerpiece because it enables us to really understand what is being caused. There's even a new organization you see at the bottom called the World Weather Attribution Organization, based in England, with scientists from around the world using statistical methods to be able to publish, as I just said, their findings on what can be attributed to climate change, which was named attribution as one of the top 10 new technologies by MIT a few years ago. So this stuff has been taken very seriously by the technical community. I imagine partly because we're all aware that the citizenry in certain sectors in particular, but all around the world, hasn't yet bought into just how serious the problem is. And so the alarms have been going off, and we're just trying to make people understand that. Here just the other day was an article from The Guardian, which is an online newspaper I like to read a lot. And it makes the point, not just that June, as I mentioned, and July, but also August and then September were the hottest ever. And it says that September beat the old September record by 0.5 degree centigrade, which is about a full degree Fahrenheit. So these have all been the hottest months, June, July, August, September, all in the headlines. By the end of the year, it's probably going to be yet another 2023, another year that'll be a record-setting year. So there is global warming. Now, this is a very, very useful web page. If you just go to your browser, any browser, and put the words climate and NASA in, it will give you this web address. It'll pop it up as the top item. And it's there all the time. And it changes as often as it needs to because the home page shows 6 key parameters, all that track climate change in various ways. Of course, right in the middle of the top is global temperature to cover global warming. And then the principal reason you hear about is carbon dioxide, and then some of the effects on the ice sheets and the polar cap and sea level and so on. And so you could take any one of these at any time. You could do it right now if you wanted to take the time. And you click on that plus sign, and the next page it brings up shows you a graphic with historical context of the parameter that you're talking about, so that you know that it's not just a point in time, and you know whether it's decreasing or increasing, and by how much. So here's one that is, in fact, global warming. And so the reason it starts in 1880 is that is the earliest year at which we believe we have really solid global temperature information in order to establish what the average global temperature was that year. They could say it was, go back to the 1700s or the 1600s, but the one that they really rely on is 144 years ago in 1880. And so you see for the first half of the time since then, about 60 or 70 years, not much change that couldn't be accounted for by just sort of normal natural ups and downs, which nature does. But then it took off, and since about 1970, it's been steadily going up, and it's actually accelerated in recent years. And so pretty much every year in this particular millennium, this particular century, is setting records. Sometimes the full globe, sometimes just regions, but they're all temperature records. And so we have to ask the question, what causes that? And you've all heard about the greenhouse effect. And the greenhouse, as I said to my wife today when we got in the car and she remarked about how nicely warm it was in there, of course I gave her a NASA talk. She would have kicked me, but she couldn't. At any rate, so a greenhouse does a nice job with glass, sometimes tinted glass, of taking the solar radiance coming in and not letting all of it get back out and warming things up. That's the way a greenhouse works. That's the way the Earth works. I wouldn't be talking to you. You wouldn't be alive. I wouldn't be alive if it weren't for the greenhouse effect. Turns out our neighbor, Venus, also has the greenhouse effect, except in their case, guess what took off? Probably billions of years ago. Carbon dioxide in the atmosphere. Now it's 900 degrees on the surface, with 92 times the density in their atmosphere of carbon dioxide that we have. So we don't ever want that to happen, and we aren't headed towards something like that. But things are changing, and they're changing with the principal gases that we call the greenhouse gases. Carbon dioxide you hear the most about. Methane you're going to hear more and more about. And water vapor, frankly, we can't do a lot about. They all are chemicals in the atmosphere that because they're there, they trap heat and they keep us warm. They keep things temperate. So what we're concerned about isn't the greenhouse effect, it's the intensification of it that's caused by the rapid increase of any of the greenhouse gases, which traps more and more heat. And so we're going to talk about methane in a minute, but first let's talk about the one that we read the most about and hear the most about, carbon dioxide. So when you go to that home page and click on CO2, here's the graph that comes up. And so you can learn a couple things from this graph. Not only is it, as we say, monotonically increasing, it never goes back down since the time that this is shown, which is only an 18-year period. So you need to realize that scientists would not care much about this at all until they learned a whole lot more. Because you want to make sure that you know the context for this. Who knows that 18 years before that, maybe it was 420, and over an 18-year period it came down and went back up, in which case it's just kind of a cycle. So you need to have the historical context, and you also need to recognize that when people do graphs and they show them like this, you check the left-hand axis there and make sure that if it's 0, that's really meaningful. It starts at 380, goes up to 420. Maybe that's a normal swing over an 18-year period. So let's look at the historical context. And there it is. And this may surprise you. It surprised me at first until I talked to a number of the technical people about it. But with ice cores and understanding geology, we can track the chemistry of the atmosphere going back not just decades and centuries and millennia, but hundreds of thousands of years. And so we now know that carbon dioxide in the atmosphere has gone through this up and down excursion over periods of hundreds of thousands of years. And I think it's kind of remarkable how regular it is. But at any rate, the big point is it went from a minimum of 180 parts per million up to 300 and back down and up and down and up and down until 1950, in which case, if you track every year, and now we got a compressed time scale, so it looks like I just drew a straight line, but all the data points go just like that. It's been straight up, and it's gone up in range exactly the same amount that was the total range below the maximum before. That's a pretty alarming change in the concentration of carbon dioxide. Not unexpected to some pretty smart people that have understood atmospheric chemistry and what it is that puts out carbon dioxide, like the burning of fossil fuels. So that's what we're going to talk about. Here we have it. We've got just a wonderful picture that NASA provided us that shows all those internal combustion engines that burn gasoline, trucks and cars and so on. Maybe some of them burn diesel fuel, same thing. We've got chemical plants that put out carbon dioxide. We've got all manner of electricity generating systems from coal to oil and gas, all putting carbon dioxide into the atmosphere. And instead of having just 1 billion people, which we did 250 years ago on Earth, we've got 8 billion now. And we've got a whole bunch of people in places like China, and maybe before very long, India, where if you combine the population, it's like 1/3 of the world's population that are increasingly going to want cars and trucks. And so it's pretty alarming at how much fossil fuel is burned every year, and it isn't going down. But despite what you might hear from some quarters of the media, this isn't news at all. As a matter of fact, somebody that all of us as contemporaries were very familiar with because we loved our phones even when we were kids, Alexander Graham Bell, in 1917, this is something that he stated publicly. He knew Henry Ford. Henry Ford had just perfected his assembly line, and so the millionth Model T came off the assembly line in 1915. And Bell, who'd watched coal burning things in the 19th century, now was seeing cars just being bought and bought and bought, burning gasoline. And he said, because he understood atmospheric chemistry enough, we're going to have a hothouse here. And he even suggested that maybe we ought to look into solar energy. Over 100 years ago. So it's human nature, but it's also organizations that get in the way. We aren't doing anything about something that we've known about for a very long time. And there is more. It's bad enough that we're putting more into the atmosphere. We're actually making it difficult to take it out of the atmosphere by the main mechanism, which is the wonderful thing called photosynthesis of vegetation. And so we have been clear-cutting agricultural fields, forests, for decades now. Here's an American example, and the worst one is in the Amazon rainforest, which you've probably read about. But we're able to see this because we have satellites now that for decades have been taking images of the same fields, and you can just see the patchwork show up. And picture the fact that those plants, those treetops, are not any longer taking carbon dioxide out of the atmosphere and giving us oxygen back to breathe. You know, the Amazon's referred to as the lungs of the world, and less is that the case. So we're doing things wrong in both directions. I thought it'd be interesting to mention, some of you have connections to the local area, and I actually worked at GE Aerospace in King of Prussia, and I actually did work some on Landsat, but it's a NASA spacecraft that was first launched, I think, in '72. So what, 51 years ago? It won a big award called the Collier Trophy, which is awarded not even every year to the top aerospace thing. And that's because for the first time, we had constant looks down on the Earth as Landsat passed over it. We're now in the 8th generation of Landsat. We have the longest continuous data stream ever from Landsat held in our databases of the entire surface of the Earth, visited with Landsat's instruments over and over again for now over 50 years. So now this looks something like, but it's slightly different than the home page I showed, because just recently NASA decided they needed to add methane to the home page. So there it is. It displaced one of the 6, so it's a little cumbersome. I think they'll probably fix the graphic, but this is what it looks like if you go to that website that I mentioned before. And you'll see that now we're starting to worry about methane, the second most important greenhouse gas, because it also is a byproduct of what we're doing as humans. And so here's a curve. If you click on that plus sign there, you'll see this curve going back for about, about 30 years. And so it comes up pretty steadily, levels out, and then is kind of accelerating right now in the last 10 years. But the main point is how much it's up over the beginning of the Industrial Revolution a couple hundred years ago. And the fact, and this is really important, that the same volume of methane put into the atmosphere is 30 times more effective at trapping heat and not letting it go back off into space. And so it's worse as a heat trapper than carbon dioxide is. Now the other side of that coin is methane doesn't linger for more than 10 or 15 years, I'm told, in the atmosphere. So if you just let time pass and don't keep adding it, then that won't be a heat trapping gas in the atmosphere, where CO2 is there for centuries. So if we could actually regulate methane better and stop putting as much in, the problem would start to take care of itself, because it's become a major part of global warming. About 25% of global warming is caused by methane, not just the carbon dioxide. And here's a qualitative look at how nature does, because nature is always putting CH4, methane, into the atmosphere. And there are several major things that man is doing that's putting methane there. The first one, livestock, gets a lot of press, because basically every living being that takes in food has some kind of digestive process, and in most cases gives off methane, among other things. And livestock do it in large amounts. And so people do too. But the point is that it is, as you can see, a major part of the man's contribution that could be controlled if we had less livestock. Now, I'm not saying we should necessarily cut out anything that we couldn't handle, but it's something to think about. The second one is not the fossil fuel burning that CO2 is, but it's the way we handle fossil fuels, and in particular, natural gas. Every time you open up a pocket of oil in the ground, there's natural gas there with it. Every time you go and do a shale oil thing with fracking in northern Pennsylvania, for example, and open the ground up, there's both oil and there's also natural gas there. You want to get the gas because natural gas, mostly methane is what it is what they commercially want to provide to us as a fuel, and it's a nice fuel. When it burns, it does give off carbon dioxide. But the fact is that it's mishandled in so many industrial operations and so many fracking operations that all manner of volume of methane is being released into the atmosphere all the time. If you go past a refinery, maybe you remember seeing this tall tower with a flare at the top that's burning. It's burning off while they're refining oil. They get gas with it, and so they have to do something with it. And so they send it up the stack, they light it, and there's this flare burning that'll burn it off. Except that those go out all the time, and they don't do anything about them. You go to the oil fields in the Saudi desert, and you find that sometimes you'll see fires. I've flown over it at night and seen fires on the ground, but not all of them burn off the natural gas that's coming up where they're pumping oil. The shale oil operations in northern Pennsylvania have been faulted for the fact that they have regulations that require them to cap the leaks and not let it leak, but they don't actually enforce it much, and there's still stuff being leaked. So it's something that we could get a handle on if we would. Landfills, because there's a lot of decay going on, give off some CH4, some methane naturally. So here's another sort of natural cause, but it's related to man's activities in warming the atmosphere. You're looking down on the Arctic Ocean. There's good old North Pole right in the center there. On the right is Russia and Scandinavia. On the left is Alaska and Canada and Greenland. And so you've got oriented there. And toward the pole, there's all this frozen area not very far below the surface called permafrost. Wonderfully, nicely frozen, not just soil, but lots of living things that are down there, vegetation that's down there, but it's frozen solid. But as you warm the surface year after year, that permafrost level is coming up. And as it comes up, it thaws the vegetation and it thaws the microbes that are in there. And the microbes love that carbon, and so they digest it and they give off methane. That's the mechanism. And so there's lots of methane coming now, and hopefully, yeah, I've put this into motion. So this is a European Space Agency picture actually showing the extent of permafrost shrinking over the last decade or decade and a half. And it takes a while to get through, but trust me, it's decreased a lot in area. And every time it decreases by a number of square miles, that's a certain amount of methane that's been released. And just published was a new mechanism that's been understood that's different than the one where you have some living being, in this case microbes, digesting something. In this case, it's just direct methane release of the gas that's been trapped very deep underground. And the example that they've shown for it is the place you see with the arrow there north of Scandinavia. It actually belongs to Norway. It's called the Svalbard Islands. And they're very close to the North Pole. And they have the distinction of being the place that's warmed the most rapidly in the last 50 years. That's almost 7 degrees, or it's more than 7 degrees Fahrenheit that it's warmed on average in Svalbard. And what's happening to that wonderful landscape that was just filled with glaciers is the glaciers have melted. And the glaciers were a cryospheric cap, a frozen cap, sitting on top of springs where the oil and gas reserves are underneath, and now the gas is bubbling up. So they've taken this ice cap off, and they're getting lots and lots of ancient methane released into the atmosphere that wouldn't have been there if the glaciers had stayed. So it's a growing problem. So I mentioned before James Hansen, the director of the Goddard Institute of Space Studies, who happened to also be a climate scientist, and working in the 70s and 80s, he and his colleagues became alarmed at what they were seeing with regard to warming. And fortunately, in that time period, people wanted to pay attention to voices who had data and had findings that were something that the government should care about. And so, in a way that's almost impossible for us to picture today, he was invited to go to the Senate in 1988 and testify. This was under Reagan, a Republican administration, testify before Republican and Democratic senators about his findings, where he said such things as this. This was 35 years ago. And they were so impressed with the basis for this and how much it mattered that they went to the UN. Again, imagine a team of Republican and Democratic senators going to New York to the UN. And they started in motion what got established as the Intergovernmental Panel on Climate Change. Now, hopefully, a lot of you have heard of the IPCC. It's in the news a lot. It's been around, as you see, for 35 years now. It's made up, it isn't like a UN agency where they hire a bunch of people. It's a UN agency that was set up to provide an umbrella over all the organizations around the world, not just in the US, that care about climate change. And so they ended up with thousands of scientists and other kinds of technical experts since then that have been working out of all those different countries and all their different research and universities and so on, institutes. And every half dozen years or so, they publish another assessment report. The most recent one, just by coincidence, came out in March. There's a handout that I've provided that's got this website on it if you want to look at it. It's a really, really extensive report, but you can search in it and find things about almost any question you might have. And it's not that they're the be-all and end-all, but they're making the most of all the minds around the world addressing this same global problem and providing peer review of each other in order to have things that they can all support, because their point is to have their policymakers. If they're in South Korea, they're doing it to make sure that the president of South Korea knows what to say to the Congress, and vice versa. It's to help the people that are leading the world, supposedly, make the right decisions and give them projections to act on and suggestions about what to do. And so it was viewed as so effective by the Nobel Committee in 2007 that they awarded them the Nobel Peace Prize. And I wasn't paying attention back then. I didn't start paying a lot of attention till about 10 years ago. That's a confession I'll make. But I looked back, and of course it's true. And the point is that this is about not just climate change, but man-made climate change. And they wanted the IPCC to be recognized for their accomplishments. But when the award was made, they made the award jointly to the greatest spokesman for what the IPCC had been doing. Because Al Gore, once he wasn't able to become president in 2000, was a very visible, very vocal, intelligent man, and he'd been concerned about this for some time, so he used his platform, not just in the US, but to go around the world. You know, what was it called? An Inconvenient Truth? Had a wonderful movie that was basically PowerPoint slides of the IPCC's findings. So they worked hand in glove, helping each other. And in one of those sad, sad occurrences of history, the fact that it's Al Gore may partly account for one particular political party that doesn't seem to want to accept this. It's beyond my understanding. But at any rate, it is what it is, as they say. And so I thought you'd be interested in that. So how do they do their work? Because the Earth is really, really complex. And so we're talking about understanding how everything is working together, interacting, weather interacting with ocean currents, interacting with, vegetation growth, interacting with weather events, and so on. How do you do all that? Well, you break it down into pieces because they're all dynamic. Everything's changing all the time. They're all complex. If we didn't have the high-speed computers that we now have, if we didn't have the ability to do this kind of math modeling, which we didn't 7,500 years ago, we wouldn't be able to run models, as they say. So in one of their every 6-year assessment reports, the IPCC polled, they had a team of their scientists from all different countries go around the world. They published a whole chapter on this, and they found what different organizations were using as so-called climate models. And so they picked the 23 best. And each of them has got a separate model for each of the 4 spheres: the cryosphere, the hydrosphere, the atmosphere, the biosphere. Covers all of Earth's systems. And if that weren't hard enough, when you go to the interface between these spheres, like the interface between the ocean and weather systems in the atmosphere, is pretty tricky. And so they all had to have a coupling model too, to show how to handle things at the interface. So these are mathematical models that ended up being run by all these organizations in order to provide data that could be agreed upon every 6 years or so by these scientists in different chapters of their report, so that they could all agree and give exactly the same findings, projections, recommendations to their decision makers. And they did it speaking a language that was much easier to understand than a bunch of tables and numbers and spreadsheets. They just gave them scenarios like, if you eliminate fossil fuel burning cars at a rate of 10% every 2 years for the next 10 years, then here's going to be the impact on carbon dioxide. And they had to have econometricians in there because there would be an impact then on the economics of the nation, and sociologists that say, well, people aren't going to accept that, so we're going to model it this way. Just a lot of people, thousands of people working on these things, but they've turned out to be very useful. Obama used this very well in 2014. He took the results that the people from China and India, among all the other nations that went to the Paris summit, had come up with, and he went back to India and talked to the president, and he went back to China and talked to the president to try to strong arm a little bit. Not by coincidence, I'm talking about those two countries with a third of the world's population developing very fast, adding to the fossil fuel burning very fast. And if we can't get those countries to get a hold of it, I'm not sure what we do. But at any rate, my point is some decision makers really do try to do things with this. So that's a wonderful thing to have mathematical models and computers, but you have to feed data into them. And 100 years ago, we had some ocean buoys to keep track of sea level. We had the odd, calibrated set of temperature readings for a bunch of international ports. But now we need data everywhere all the time, and this is what we have. And so thank goodness we are able to, with polar orbiting satellites, the ones that go around over the poles while the Earth goes around this way, and therefore you see the same place on the ground over and over again, take the same data with the same instruments, and therefore you can feed the models with repeated sets of the same measurements year after year, that sort of thing. So here's a good graphic just to illustrate what I'm talking about. And this is by no means, excuse me, this is by no means all of NASA's spacecraft. Most of them, as you can see, are polar orbiting. There are a few that aren't. But the point is that they go around day by day, and the way a low Earth orbiter works, it orbits 14 or 15 times a day. It's just the way, Newton's gravity works out, which is about 100 times a week, which is about 500 times a year. And most satellites last for many years. So we're talking about thousands of measurements from satellites that in many cases have more than one instrument on board. Here is the look at NASA's free-flying, low Earth orbiting Earth sciences satellites today. They change from year to year. And there are 13 shown here at the moment. We aren't going to talk about many of them, much other than mentioning it, but some of them are kind of self-explanatory. In the middle row there on the right, it says OCO2, which you might think is orbiting CO2. It isn't. It's orbiting carbon observatory generation 2, because there was an OCO1 before that, and now this has replaced it. GPM next to it is the Global Precipitation Monitor. So again, they all have some relationship to collecting data that's relevant to the Earth's 4 spheres and different from other platforms. So we're getting a lot out of NASA's free-flying, low Earth orbiting spacecraft. In addition, the International Space Station astronauts regularly take up experiments that are put onto those odd extensions on the outside there. They travel outside and hook them up, turn them on, and they gather data using the International Space Station as the platform until they want to change it out with a later version or something. And so some of them are for the biosphere. In the case of JEDI there, it allows them not just to see the tree canopies, but to get information that allows them to see the depth of the tree cover, the forest structure in 3D. In the case of EMIT here, they put it up to look at dust in the atmosphere, but it turns out that it gives you a nice direct measurement of methane sources. So they're using it for that. There's the 3rd generation of that carbon monitoring satellite that I said before. This one, since it's on the International Space Station, it isn't going around the Earth like this. It's in a lower inclination, so it doesn't cover the poles, but it does its own thing and it's useful data. And then finally, I thought it was important to mention that you'll hear sometimes from some of the deniers that all we're seeing is just the normal excursions of solar energy coming into the Earth. And it's true. The sun has cycles. The sun's radiance on Earth changes. And so this particular spacecraft is measuring what's coming in from the sun all the time and confirming what we kind of already knew, which is there's no correlation between the little bit of changes in the sun's heat and what's actually happening in the atmosphere. It's not the cause of global warming. In addition to NASA, there are space agencies in all the developed countries. Some have their own launch vehicles and launch sites, like India does. They've had Earth observing satellites going back 35 years. 9 of them in the last 20 years have been for climate and the environment. The Chinese, likewise, they started a little later, but they've got lots and lots of Earth observing satellites, and they share some of the data. They've got one recently that they put up called Tansat, which in Chinese apparently means something like carbon monitoring, and it's very much like OCO2 that we have. So they're looking at CO2 also. The Japanese, same thing, about the same length of time as the Indians. The Indians and the Chinese and the Japanese all have their own rockets. They all have their own launch sites and so on. And in the case of Japan here, you see that they've got a couple relatively recent spacecraft constellations that are directly measuring CO2 and methane. So everybody's trying to keep track of the same things because it's a global problem. And then the European Space Agency has had lots and lots of down-looking Earth resources satellites under the name of Sentinel, which is the latest sea level measurement satellite, Cryosat looking at the ice sheets and ice caps and so on. And Russia, Brazil, Argentina, other nations also have some. So if you added it all up, I mean, there are probably at least 100 satellites in maybe 50 to 75 programs, each with at least one instrument, all looking down, all getting 500 passes a year. So lots and lots of data is being gotten and feeding these models as needed. So let's take a look at the impacts now. We've got those 4 spheres I talked about: atmosphere, biosphere, hydrosphere, and cryosphere are the fancy names for them. But you have the greenhouse gases now, CO2 and methane, going into the atmosphere, mostly into the atmosphere, but some of it goes directly into the ocean. And among other things, it makes the ocean more acid. But the heat of the atmosphere goes into the ocean. Something like 90% of the sun's heat goes into the ocean and warms the oceans up. But between the oceans that are getting warmer and the atmosphere directly being warmer, you have lots of global warming and lots of impacts on each of the 4 spheres. So for example, rain, snow, wind, wildfires, all the things we hear about all the time are impacts on the land. And the attribution technology that we have now is going to allow us to at least make it clear which things wouldn't have, you know, like a drought wouldn't have been that long or that deep, or a hurricane wouldn't have gotten worse that as rapidly as that if you didn't have climate change problems. In the cryosphere, we look at the ice cap, the ice sheets, and the glaciers, and of course the ocean. We care a lot about what the whole thing is impacting directly and causing people now real pain around the world, which is sea level rise. And before I get to the sea level rise, the NASA climate science leader talked to us within the last month or so and told us because of an El Nino that's taking place this year, and you may have read about this, it's been in the news lately, but basically an El Nino is manifested when the eastern equatorial Pacific, you know, under the Hawaiian Islands, kind of coming all the way up against the Americas landmass, when that is warmer than it usually is, which doesn't happen but once every 6 to 10 years, that's an El Nino. And it causes weather changes around the world. In particular, in the next year. And so the El Nino that's been building up this year is going to cause next year probably to be hotter than this year. And this year is probably going to be the hottest ever. So we're into it. So let's look at sea level. Here's something that we're able to plot very precisely for exactly 30 years, because at the beginning of that time was the first NASA down-looking laser altimeter, basically a spacecraft flying around the world this way, shooting a signal down that comes right back up. And the length of time it takes is very precise and is very easy to correlate with the height of what's underneath it. So you see the height of all the mountains and the land masses, but in this case, we want to be able to see something that we could never sample in enough places, and that's where the oceans are in terms of their height. So now we have a perfect understanding of the average sea level going back 30 years because of these spacecraft. And so now again, here we are, and you need to be skeptical. You don't know what was the case before this. Maybe it was this high many times before. But as it turns out, we can look back historically, and we have very good data on this. And so we go back 9,000 years. And 9,000 years was about the time when the last ice age, where all the things that filled the Finger Lakes and the Great Lakes and everything, all that ice melted back towards the pole. Well, the ice went somewhere. It went mostly into the oceans, and it filled them back up again. And they stabilized about 9,000 years ago. And until very recently, about 1/4 of a millimeter a year is how much the oceans went up. And they did go up steadily, but that works out to, if you look at a millennium, 1,000 years, 1,000 times that is 0.25 meters, which is about 10 inches. So 10 inches of sea level rise in 1,000 years, that's the kind of thing that humanity can figure out a way to deal with. Unfortunately, it didn't stay there. Starting in the Industrial Revolution, it started to rise more again because something had happened. Let's say fossil fuel burning had put greenhouse gases in the atmosphere, and the oceans started rising more rapidly. So in the last century, on average, they rose at a rate about 8 times they had for the thousands of years before then. And then lo and behold, we get to the end of the last century, and we finally had perfect measurements of sea level rise, and we see a slope that isn't just 12 times, it's 14 times the historic rates, but it's going up. It's still increasing. And if you read the IPCC reports, it says exactly these things. And so the big concern here is what is going to be the impact of that sea level rise, because it's getting worse every decade or so. And there are certain things that could trigger it getting worse much faster if the ice starts to melt at much faster rates. I'll just talk through this quickly. It's a little too busy, but the point is that with the present rate of 3.4 millimeters, which we measure, that's about 14 inches a century. And again, in 100 years, could we handle a foot rise? It turns out a foot vertical rise changes things a lot in beach areas and in areas that are adjacent to oceans, like many of the ports are, like New York City, for example. And the change is accelerating, so the question really becomes, can we handle it? That's the problem. Well, there were 1 billion of us, finally, for the first time, in 1804. It took over a century to get the 2nd billion, and in less than a century, we've now got 8 billion. And so more than half of the people in the world, between all the island nations and people just liking to live near water, live very close to the water. And so what's going to happen with a foot of rise, you're going to take away not just clear day, high tide flooding in Miami and in southern Louisiana. That's going to happen everywhere, including places like New York. The calculations say that all 3 of the airport's runways, if they aren't diked off somehow, will be flooded with a foot of sea level rise. San Francisco, same thing. Things are going to have to move. And so unless we do something, there are big changes coming. We're going to see climate migrants in increasing numbers. We have enough problem handling a variety of kinds of migrants right now in Europe and at our southern border and so on. We're now going to see increasing numbers of people that can't live in their low-lying coastal areas or their islands in the Pacific in particular anymore. Somebody did an interesting study, and what they did, they looked at all the counties around the edge of the US. Cape May County is an example. So you take all those and add them together, and it turns out the population can be calculated, of course, so can the GDP. And it would be the third highest GDP in the world. In other words, those coastal counties in the US, and probably other nations as well, account for an awful lot of the economic might. And they are the ones that are going to be most clearly impacted by migrants on the one hand, but also creating migrants and creating industries that have to migrate away from the shore. This is all with just a foot rise. And that's what's in the latest IPCC report as kind of the midpoint of, I'm sorry, I'm wrong, 3 feet rise at the end of this century is what's in there. I just looked at this today, or 30 inches I think is pretty much what it came out at. My point is that we're in trouble with sea level rise, and we haven't even gotten to the worst of it yet. So here's an area of the world, Western Pacific, filled with thousands of little islands. A number of them we have relationships with, like Micronesia and the Marshall Islands. Marshall Islands has got a status of being an associate state of the United States. I don't know if you're aware of that. And so we've got a bunch of relationships, but even for the ones we don't, there are lots and lots of people on little islands, and there's lots of low-lying area in Southeast Asia there. And there's also half the world's population. And maybe 5 years ago, most people wouldn't have seen this, but I look for things like this now. There was a headline in the Inquirer from a group that identified themselves as the Vulnerable 19. 19 little nations from this part of the world that publicized the fact, gave themselves that name, and said, we contribute almost no greenhouse gases to the atmosphere, and we're the ones where our fields are being flooded, our people are having to move. You're hitting us. Can you please do something about it? And they made a big noise at the recent climate summit, which I think was in Spain. But at any rate, you're starting to hear from them. So a couple quick examples. There's a place that's called Bangladesh, which I think we grew up learning was East Pakistan, if you remember. And so Bangladesh, it turns out, has got a lot of low-lying land. And here's a farmer standing in what was his fields with his house up the beach about 20 meters away. And that's the kind of thing that happened. This was a New York Times article 5 years ago. So obviously, some of these low-lying places are being impacted already. Here's another one, Marshall Islands teenagers. So you can kind of picture they're, getting ready for a choir concert or something or other, except that they're in Springdale, Arkansas, because their homeland, the Marshall Islands, couldn't handle the sea level rise, and they had to move them to Arkansas. And the theme of this beauty contest they're preparing for was climate change, which is sort of ironic, I thought. So I wanted to put this in just to remind us all of who's responsible. The scale at the bottom shows CO2 emissions going from deep green to lots and lots in the brown. And there are only 2 brown nations, us and the Chinese. This is based on total CO2 emissions. And China is first. China has 4 times as many people as we do. And their total CO2 leads the list. Until 2007, our total led the list, but China's, as we know, rapidly industrialized. But the most interesting thing isn't that number, and there's a handout that you're going to get that's got this number on it, but it's the per capita CO2, it's basically our carbon footprint. You've heard that term. We're first. China is well down the list, fortunately. And fortunately, because with 4 times as many people, if they ever have the same per capita contribution, it's like game over. India is maybe 1/10 of the US at this point in terms of per capita. But the point is that each of us, and I say this to myself all the time, needs to think about the fact that we like to get on planes and get in our cars whenever we want to, and put our thermostats wherever we want to, and put whatever we want to on our lawns and stuff, all that stuff adds up to us being the carbon contributors and have always been the top per capita carbon contributors. The Europeans about 40 years ago in the 80s were tied with us on a per capita basis. They've gone way down. They made some decisions about coal-fired plants, and they just have really improved things over there. They're well behind us now in terms of per capita. There are many things that we can do. Now I'm going to finish with an area that is the one that's responsible for sea level rise. And it's always kind of interesting to me to couple geography into with other things. And so on the left, we've got the North Pole, and on the right, the South Pole. And the contrast is just amazing. We have an ocean surrounded by continents, and we have a continent surrounded by ocean. They're kind of the opposite. And in the case of Antarctica, it's more than 1,000 miles across. It's got mountains, but on top of all of it is an ice sheet that's more than a mile thick in many cases. And that ice sheet extends way out into something called an ice shelf that's partly in the ocean and partly not. It's tied to the ice sheet. So on the left there, we have a situation where as global warming takes place on the polar ice cap, it melts. And of course it does it every year, and it has always done that in the summertime. It melts from September till about April. It grows back, okay? And when it melts, what happens to the sea level? And the answer is nothing. Just like when you put some ice cubes in your drink and the level goes up, and you watch the level, when the ice cubes melt, the level doesn't change. The water's already in there with the ice. The water's already in the Arctic Ocean. So the Arctic polar melting is not a problem causing sea level rise. It's the canary in the coal mine telling us, with a loud alarm, that we've got global warming, as you'll see in a minute when you see how that polar ice cap has melted. But on the right, we've got an ice sheet sitting on top of the land. And when that ice melts off, it adds to the water, and that's a direct way to give you sea level rise. So here are satellite observations looking at the area of the polar ice cap going back to 1979. And just to kind of highlight, in 79, at the end of the melting season, which is in September, before it starts to get bigger again, it was 7 million square kilometers. In 2012, it was exactly half that in September. And it's predicted that at some point in the next couple decades, probably it's going to melt completely in the summer. It doesn't mean it's gone. It'll come back in the wintertime. But there are some people like polar bears that are out of luck. They're already out of luck. You've probably heard about the habitat loss that they've had. And it isn't just the aerial extent of the ice, it's gotten thinner. We've got something called GRACE satellites, 2 satellites in tandem that allow us to measure the density of everything below them, the gravitational effect. And so when you go over an ice mass, you can tell how thick it is as well as what extent it has. And the polar ice cap has been thinning out, which means it'll break up more easily as well. This is also bad news for reflected solar heat. One of the good things about ice is it reflects a lot of the sunlight back into space and it doesn't warm the atmosphere. But if you melt that ice, it goes into the water or onto the land, and it kind of creates a positive feedback loop to cause it to melt some more. So we've got a big problem there with the polar ice cap melting and taking away some of the ice that's reflecting. Greenland has given us an indication of ice that goes off the land straight into the water that's a little closer than Antarctica and has actually been worse in the last 25 years. So they've got an ice sheet like Antarctica. It's a mile or so thick in many places. It communicates with the ocean down through these fjords, which have glaciers. And so we've watched some well-known glaciers recede at extraordinarily fast rates as the ice drops off into the ocean, which, since it was sitting on land, means it's adding to the sea level rise. And so we've been able to use satellites to come up with estimates of the amount of ice mass that's been lost year by year for the last 20 years here. So 273 gigatons per year. And I look at that and I say, wow, that's a big number. And I haven't got the slightest idea what it means, but it looks big. But when you translate it into, that's equivalent to 3/4 of a millimeter. Remember, for 9,000 years, everything caused the sea level to rise 1/3 of that. And now Greenland ice melting is causing it to is adding 3 times that amount to sea level rise every year. If you add the Antarctica ice sheet melting, that accounts for about 1/3 of the rise. If you add the glaciers melting, that's another 1/3. And the final 1/3 is something that we all learned about in our earliest science classes, which is when you warm a liquid up, what does it do? It expands. Well, the oceans have been warmer every year for decades. And so the oceans are expanding, and that in itself is causing the sea level to rise. So that's the 3 principal elements of sea level rise. Now we're going to get to the problem that we're most worried about, because Antarctica's ice sheet is much, much bigger than Greenland. And until recently, it didn't have as much melting on an annual basis, but we perhaps hadn't been looking at it closely enough, and now we have been. And we found things like this. That little upper right, the red box there shows on West Antarctica where the area is that we've blown up in that picture. And it's a fairly large glacier that's sitting there adjacent to the ocean, and it's been given the name for a reason that you'll understand, as opposed to its normal name of Thwaites. And that's because it's had such a high ice loss rate for the last 30 years. 4% of sea level rise is caused just by that one little glacier there. So what have we done? We've taken expeditions there, we've taken planes in addition to the spacecraft we're looking with, and so we've taken a lot more measurements over the last 10, 15 years. And the Brits have worked with us to where we've had a joint expedition with a ship, an aircraft. We've mapped the seafloor there in front of the glaciers. We've looked underneath the glacier. There's been a ground penetrating radar, which allows you to see cracks and voids and so on in the ice. We've used a gravimeter, which is a way of understanding the thickness of the ice. And so finally, just a couple of years ago, they drilled a hole 2,000 feet through the ice there at the edge to where it would go straight down to the water underneath, and they dropped a robot. And basically it was a metal tube about maybe 10 feet tall, and on one end was a propeller, and on the other end was a camera. And they just lowered it down and let it motor around underneath and take pictures of what was underneath the ice sheet. And what they found was kind of alarming. And the best way to understand it for me is to picture the Grand Canyon with all of the little tributaries and steep stuff, and flip it upside down and picture that as the bottom of the ice sheet, because it's not a smooth bottom. It's like that, which means that all this warm water can find all that area to get into and slowly but surely cause things to break up more rapidly and erode. And so the calculations most recently published were that if Thwaites itself breaks up, which it looks like it will before too long based on how much breakup they're seeing and how rapidly it's already been losing ice, we'll see another couple feet of sea level rise out of that. And there's no reason to believe that it's so special that there won't be others. And if others do the same thing, we could have 8 feet of sea level rise by the end of the century. If we have 9 or 10 feet of sea level rise by the end of the century. It's our grandkids and great-grandkids are going to have a challenge that it's just really hard to understand. There are going to be so many people moving on the planet. It's really pretty bad. So, summarize. We've got 144 years of data, but in the last 13 years, we've had 10 warmest years ever, and then this year is going to be one more, probably next year too. The oceans have warmed every year since the 90s. They're absorbing all kinds of warming from the sun and from the atmospheric warming. We see this rapid accelerating breakup of the ice sheets and melting. And perhaps worst of all, where we have so-called climate programs that are being better funded under this administration, and I don't mean to fault the administration, but it sure hasn't had much of an impact yet. We just had our second year in a row of greenhouse gas emissions from the US increasing again. Well, that's nice. I mean, that must mean it went down. Well, when did it go down? It went down when we all stayed home and didn't drive our cars or fly our planes for 4 or 5 months. I mean, that was a singularity, and I kept looking for the media to jump on that, and maybe the scientific community too, and say, this is an experiment we didn't want or expect, but look what we're learning, maybe we better pay attention. We didn't. We're right back at it. Nobody really wanted to hear that. I mean, if that isn't showing that there's man-made global warming, I don't know what is. At any rate, so there are negative trends. A little bit of good news I found. I had to look hard, but there's a budget of how much of the US's power grid is contributed to by coal-fired and oil-fired and gas-fired and nuclear and, you know, everything. And it turns out renewable finally has passed coal as the contributor. So hopefully that's going to be much more rapid and pass a lot of other things in the next decades to come, but it's hard to find much good news. So I very much appreciate your attention. I do want to say one thing. I would like questions, but I've given this talk to a lot of audiences, and I've gotten the question probably less in recent years than I did 10 years ago. What should we do about this, John? My answer tended to be, initially I was a little bashful to say you need to look at who you're voting for, but that's obviously one thing that matters a lot. But it's only in talking to some groups that have their own ideas that I've been somewhat encouraged. And now this is the second group I've found, thanks to Ben and a number of people. You folks raised your hands. Hopefully there will be more and more people like that. The idea of people that are educated, aware, interested, and actually care about their kids and grandkids, sitting down and working through the hard, kind of boring work sometimes of what can we actually impact. Maybe it's going to have to do with your individual practices. Maybe it's just going to have to do with the things that you're already working on with regard to how the whole community can come together and make decisions about your heating systems or your lawn care systems as examples that you're already working on. These things really encourage me. And so I'm going to share them with other people as I go, but I really applaud you guys for that. And I have to say, it's given me a little bit of hope, and I've talked to a lot of people about this. And I think it's not just a great idea here, but I hope it can spread. Anyway, thank you. Wayne's got one. Wayne, what? Okay.
talking about climate change and sea level rise. Try this. There we go.
There we go.
Yeah. Warren Gifford. We moved here in April 3rd. Talking about sea level rise, we were flooded out by Sandy. We had 19 inches of water in our house, and our front door was supposedly 11 feet above sea level. So we moved to higher ground. So if you think this is something that's coming in the future, it's been here and gone.
Wow. Yeah, and the New York City subways have been flooded now at least once really badly. It's going to happen more and more.
Could you say once more the couple of things that encourage you? You have to wait for the microphone. You have to wait for the microphone.
Yes, sir.
John, that's an outstanding talk, well put together.
Thank you.
Just an observation, there is another area that is very critical, and that is the Ganges River in India. And the Alps are melting at a very, very high rate, and right now the Ganges is flowing nice and clean and better than it ever has in modern time. However, that is the doomsday of what is going to happen as the Alps continue to melt, and now the Ganges River will decrease, and a third of the population in India will be suffering there.
Wow. I can believe it. I mean, the density there is something, and the amount of snow cover in those mountains is something, ice cover. Yes, ma'am.
No, I just wondered if you would say that you said there were a couple of things that encouraged you. Would you mind repeating what they are?
Not at all. What encourages me is people that are aware and decide to organize and do something practical about it. And that's exactly what the SAFE initiative and a Jenner's Pond, to give somebody else some credit, they have a green initiative going on over there, similar kind of things. I learned over from there, maybe something they learned from you about Talamy areas. You familiar with those? I mean, a wonderful idea. We've naturalized our yard in West Goshen to a certain degree, but you look up and down the streets at all these green lawns, or at senior center facilities with all these big green areas, and picture that it wouldn't be so bad to let them go back to a more natural state and stop spending money burning fossil fuel with the mowers. At any rate, yeah, there are a lot of practical things that groups can come up with, and hopefully increasing number of people will. And I'm encouraged by people, you and your contemporaries, that are aware of this and want to do something about it.
Thank
really,
you so much.
really
It's
matters.
wonderful.
Thank you.
Nancy Pereira, is it on? Okay. Sir, there are people who look at the skies and watch the jets fly over, and some say that the trail is it's a chemical trail as opposed to the natural exhaust from a jet. Can you say anything about so-called chemtrails being used to affect the atmosphere in some way?
I can say I believe that what you're seeing is nothing more than ice crystals called contrails
There
with the
is
right
a-
atmospheric conditions, with basically the water vapor that's coming out of the jet exhaust. Sometimes it freezes and presents itself to us like that.
I guess I'm speaking based on what my son has been concerned about. He lives in Rhode Island. And it may be just the state of the atmosphere, but you can see a trail of exhaust from a jet that is a fairly short tail and doesn't spread out. And then there are these trails that seem to just simply cut across the sky, straight lines. The exhaust seems to fuzz out. It suggests something different.
Okay, you know, there were, I don't know how many there are anymore, but there were polluting engines 30, 40 years ago that have been cleaned up a lot. Now, maybe there's somebody in the room that knows more about this than I do. I'm kind of a layman with regard to this. But particularly on takeoff, you would see some pretty dirty exhausts. But I don't think you see that very much anymore. I think engines are a lot cleaner than they were. Now, I worked for GE, so.
Willa Nelson, I was curious about, you mentioned a community at Jennersville where it sounded like they had taken out some lawn and put in more native meadows or something like that. I'd like to know more about that. I just moved here, so I don't know what Jennersville is or where it is or anything, so maybe you could say a little more about that.
I'm gonna do something I shouldn't and pass it off to Sue or Ben, because they do know these people. Yep.
Yes, thank you so much. I don't have my mic on, so I'll take this one. Thank you for that question. That's exactly what SAFE is doing. We're gathering best practices, case studies, and sharing them. And hopefully the information we have here will not cause despair and inaction, but will rally us to speak and take action, including the committees and the people who have decision-making here. So I hope that was helpful. We will be sharing more information, including the information on the handouts that John Conrad had mentioned.
Okay. Well, I sure appreciate it, everybody. Thanks for coming.